Welcome to the series of Microsoft Azure. In the previous videos of this series, I made a walkthrough, set up Azure Data Factory from scratch, also set up SQL Server and created database and created two tables, customer and transactions. You can check the link of this video in the upper right corner. Today, I will walk through the transformation of data, where I will take the data from these two tables, transform using the data flow, and store it into the another data store. So let's get started. So first I will go to the Azure Data Factory Studio and create a new pipeline. So I will name it example Dataflow V2. I already created a video on the Dataflow. You can check the link of this video in the upper right corner. Next, I will from the activity I will take the Dataflow from the move and transform, drag it to the window, and next I will create a new data flow, and the name of this data flow will be product df. Next I will add a source here, source from where it will take or pull the data. It will basically pull the data from the SQL table. So I will name the source as the source customer. So this source actually pull the data from the customer tables, and here I will create a new datasets Azure SQL database. I already created a link service. By using this link service, I will create this dataset, and the name will be Azure SQL table customer, and the link service I choose the Simulink SQL Server DB, and the table name will be the dbo.customers. Go to the source options. I will remain same whatever is there. And here if you see the projection, you can see the column name whatever we have in the customer SQL table and their corresponding types. So basically the projection refers to the definition and the manipulation of the schema of the data as it flows through the data pipeline. A projection specifies the structure of the data, including the columns and their data types and any metadata associated with them. Next, I will add another data source another source for the transactions table. The same way, I will name it the source transaction. And here I will create new dataset for the transaction SQL table. I will name it the Azure SQL table transaction. I will select the same link service, and the table name from the drop down I will choose the transactions tables. Now if I go to the projection tab of the source transaction, I can see the column of the transactions table and corresponding data type. Next, I will perform the join operation between the customer and the transactions table. This will be inner join. So transactions table, we have the customer ID. So based on this ID, there will be join. I will name it the join customer and transaction. And you can see the join type is the inner join. If we inspect the join customer and transactions, you can see we have the customer ID corresponding name, email, and the transaction have the customer transaction have the relationship with the customer one to many. The one customer can have multiple transactions. So next I will put the aggregate where I will group by customer ID, and the name will be the aggregate transactions. And in the group by I will select the customer ID, and here we have the customer ID and aggregates. On the aggregates tab, I will collect those transactions. So I will choose the column name amount, and here amount I will perform the aggregate function, the sum of this amount, so that I can get the total amount, the transactions corresponding to the customer ID, whatever amount we have, I will get the summation of this amount as a total amount per customer ID. I will add the another column here to group by, and here I will choose the transactions ID, and I will put the expression, and here will be the count. I will count the number of transaction per customer. So now if I inspect the output, you can see we have the customer ID, amount, and the transaction ID, where I group by the customer ID and aggregate the amount and the transactions. Next, I will add the filter here to filter the aggregate data, and here I will filter based on the transactions which is greater than 1. So per customer, if the transaction is greater than 1, then I will take this results. I will take this row. I'll go to the expression builder. So I will rename the group by column. Here I will put the total transactions amount, and here I will put the total transaction count. So basically per customers, I will have the total transaction amount and the total transaction count. And next I will go to the filter, and here filter I will apply the condition total transaction count greater than 0, so that I can have the transactions which not 0. And the filter name will be basically the 3x greater than or equal to 1. Next, I will sync the result to another blob. So I will create a sync here, and if I go to the portal.azure.com, I have to create a storage account here. So I will go to the storage account from the marketplace, and next we have the storage account. I will pick the storage account, and I will create. A storage account provides the cloud-based storage that can handle a wide range of data storage needs, from unstructured data like blobs and files to structured data like tables and queues. So here I will pick the subscription pay as you go, and I already have the resource created HTML. You can check the link of you can check the video ADF from scratch how I created this resource group and all. And the storage account name, I will put the HTML blob, and the rest of the details I will keep it as it is. And next I will review and create. So you can check the deployment is in progress for the storage account. Now the deployment is completed, storage account is created. Now I will go to the resources, and I will go inside the storage account, and here we have the containers. The container is a logical grouping of all the blobs, which are essentially files. And if I go to the overview of the storage account, I can see all the details. I will create a new link service for the Azure blob we recently created to establish the connection between the ADF and the Azure blob, so that we can create the dataset and pull the container, and we can perform operations. So I will choose the Azure blob storage here, and I will name it HTML_blob, and here the authentication type will be the account key, and I will pick the connection string here. So from the Azure subscriptions, I will choose the subscription whatever I have, and the storage account name obviously the HTML blob which I created recently. Next I will test the connection, And here you can see the connection is successful. Next, I will create this link service. So you can see it's successfully created. I'll go to the Azure blob. We don't have any containers there, so I'll create a container. So I will name it the customer. Next, I will create the dataset for the sync in the data flow. So the dataset I will create to whatever transformation we made by using the data flow. By taking the customer and the transactions data, we will sync it to the Azure blob. That's why we need a dataset. So I will create the dataset by using the Azure. So I'll choose the Azure blob storage here in the dataset, and I will continue. And here I will choose the file, the CSV or the delimited text to put our result, the transformation results to the CSV file. The dataset name I will take the Azure blob syncs, and the container will be the customers, and the import schema will be none. We don't have any schema there. We don't have any file. We'll create the file freshly. Next, in the data flow, I will select this Azure blob sync, and I will choose the allow schema drift. Allow schema drift options, you can see, is a feature in the Azure Data Factory data flows that enables data transformation to handle dynamic changes in the schema of the incoming data. This is particularly useful in the scenario where the structure of the data might change over time, such as adding or removing columns, changing data types, or modifying column names. And the data flow, I will name this data flow as customer transaction DF. And next, I will enable the data flow debug. In Azure Data Factory, Dataflow debug with auto-resolves integration runtime provides a way to interactively test and debug your data flow in a managed and simplified environment. Whereas the auto-resolves integration runtime is a default and managed integration runtime that Azure Data Factory uses to execute the data flow. It dynamically provisions the necessary compute resources and handles the orchestration. So you don't need to manually configure or manage the infrastructure. The ADF will take care of it. I will put the time as 1 hour. So Dataflow debug sessions will be active for 1 hour. Azure Data Factory data flows leverage Spark cluster to execute complex data transformation at scales. So the role of the Spark clusters here, it is the computational backbone for running data flows in ADF. Apache Spark is an open source distributed computing system known for its speed, ease of use, and the sophisticated analytics capabilities. In ADF, Spark clusters are used to execute data transformation, defining the data flows. So when the data flow is executed, ADF uses an underlying Spark cluster to process the data. Data flow is translated into the Spark jobs that runs on the cluster, leveraging Spark's distributed processing capabilities. And ADF can automatically provision and manage Spark cluster through the integration runtimes. We have the two main types are the Azure integration runtimes, a fully managed runtimes that automatically handles the provisioning of the Spark clusters. And we have the self-hosted integration runtimes, allows you to bring your Spark cluster, giving you more control over configuration. In debug mode, ADF spins up a temporary Spark cluster to execute the data flow interactively. This cluster allows for the real-time data preview and testing, enabling developers to validate the transformation and troubleshooting issue. And about the optimized execution, Spark optimizes the execution plan of data flows by breaking down the transformation stages and tasks which are distributed across the cluster nodes. And to handle the large volumes of data, the cluster can scale horizontally by adding the more nodes. ADF data flows benefits from the scalability to process the big data workloads. I'll debug this pipeline to run the data flow and check how it's transformed the customer and the transaction stable data. So if I validate the pipeline, you can see we have some conditional expression where we have issues. So I have to look into the conditional expression. We do I didn't define the column name to join. So the left side we have the customer table. So I have to pick the customer ID and paste on this customer ID on the customer tables, and the transactions tables we have this customer ID. So on this customer ID we will perform the join operation. Now if I validate the pipeline is validated. Now next I will debug this pipeline. You can see the Dataflow debug is successful. It took the like 1 minute 43 seconds to transform the data. And if I show you the input and the output, the input is our tables and the output the transform data. Now I will go to the container. I will go inside the customer container, and you can see we have the file in the part because we didn't mention the file name there, and merge all the file to a single file. That's why it's created the 3 different file. And the sync so on the Azure Data Factory Studio, I will go to the sync setting we have in the Dataflow, and I will click on the setting tab, and inside setting tab we have the file name options. Here we have to choose the options output to single file, so that it output all the transformation to a single file. And for this output to single files we have to pick the set single partition, and here we have to mention the file name. So I'll put the file name filtered customer. It will be CSV, and next I will save the data flow, and next I will validate the pipeline and debug the pipeline again. You can see the pipeline debug is successful. Now I will go to the customer container in the blob, and here you can see we have the filter customer, a single file. And if I download the file and open in my local, so I didn't put the extension, that's why it didn't put the extension, but it's a CSV file. So if I put the extension CSV and open in the Excel, you can see the transform data. Here we have 2 customers and the total transaction amount and the transaction count you have. So here we took the data from the customer and the transactions table. We perform the join operation, and next the aggregation to determine the total transactions amount and the transaction count by the customer. And you can see the same data from the dataset we created. I hope you like the video, the data transformation tutorial. If you like the video, please hit the like button, please share the video, and please subscribe to my channel and keep watching for this type of Azure resource video. Thank you.